I'm Karen, and welcome back to Inquisitive Kids. Today, we will learn about the distance between parallel lines. So this is the last part to our lesson determining parallelograms. And in the previous two videos, we learned about the different methods, in total 5 different methods, of determining parallelograms. In this video, we will also be combining the new knowledge we learned today about the distance between parallelograms and the determination methods we have learned before in order to solve problems. So today we will master the concept and properties of the distance between parallel lines, use the properties of parallelograms in problems, and comprehensively apply the determination methods and properties of parallelograms. Comprehensively just means putting them together, flexibly applying them together. On straight rails, are the parallel ties sandwiched between the two rails the same length? Can you explain why or why not? The parallel ties that we are referring to in this problem and in this question is just these wooden strips over here. As you can see, they're connecting the two long metal rails. So, do you think that they are all of the same length or no? Well, that's what we're going to be finding out today. As shown, a pair of parallel lines is drawn on grid paper. Take some random points on one of the straight lines and draw a perpendicular line to the other straight line passing through these points, and then use a ruler to measure the length of the perpendicular segments between the parallel lines. So this creates these parallel segments in between. After measuring, we found that the lengths of these perpendicular line segments are all equal. So here's our prediction. The distance between the parallel lines is always equal. So let's, if that's really true, logical reasoning. As shown, lines A and B, those would be these lines here, are parallel, and A and B are any 2 points on line A. So by any 2 points, it doesn't mean it has to be what it's like drawn in the picture. It could be anywhere. This is just how it's choosing to draw it. AC is perpendicular to B and BD is perpendicular to B. Prove that AC is equal to BD. Well, here's our proof. Because AC is perpendicular to CD and BD is perpendicular to CD, we know that angles 1 and 2 are 90 degrees. Therefore, AC is parallel to BD, and AB is parallel to CD. So quadrilateral ACDB is a parallelogram. From this, we know that AC is equal to BD. Here's a conclusion. If two lines are parallel, the distance from any point on one of the straight lines to the other straight line is the same, as shown in the figure. AC is equal to BD, and this distance is called the distance between parallel lines. So in more simplified language, it would be the distance between two parallel lines always stay the same. This is the key point here. The distance between two parallel lines always stay the same. I strongly suggest you write this down in your notebook. What is the difference and connection between the distance between two parallel lines, the distance between points, and the distance between points and lines? Well, here we have a figure. There is only one distance between a point and a straight line. That is the length of the perpendicular segment of a straight line passing through a point outside the straight line. While there are infinitely many distances between parallel lines. That is, any point on a straight line can obtain the distance between two parallel lines. What it's saying is, between one point and a straight line, there's only one line segment. But between two lines, there are infinitely many pairs of points that you can select from. So here's our first problem. As shown, lines AE and BD are parallel. C is a point on BD. If AE is equal to 5 and BD is equal to 8, and the area of triangle ABD is 16, then what is the area of ACE? Well, here is our analysis. The distance between parallel lines always stay the same. So let the height be h. Therefore, the area of triangle ABD is equal to 1/2 of BD times h, which is equal to 16, and h is equal to 4. So the area of triangle ACE is equal to 1/2 of AE times h, which is equal to 1/2 times 5 times 4, which is equal to 10. So the area of triangle ACE would be 10. What if the perpendicular line segments are parallel line segments sandwiched between two line segments? Are they still equal? What if this is what's going on? From a quadrilateral whose opposite sides are parallel to each other as a parallelogram, it is easy to know that the closed figure surrounded by it is a parallelogram. So this figure right here is a parallelogram. And from the properties of a parallelogram, we know that the parallel segments sandwiched between the two parallel lines are equal. As shown in parallelogram ABCD, BN is equal to DM and BE is equal to DF. Prove that MENF is a parallelogram. Here's our proof. In parallelogram ABCD, AD is parallel to BC, and angles MDF and NBE are equal. Because DM is equal to BN and DF is equal to BE, MDF is congruent to NBE through side angle side. So MF is equal to NE and angles MFD and NEB are equal. So from this we know that angles MFE is equal to NEF and MMF is parallel to NE. Quadrilateral MENF is a parallelogram. Applying the properties and proving methods of parallelograms. Quadrilaterals AEFD and EBCF are both parallelograms. So can you please prove that ABCD is a parallelogram? From one or more of the parallelograms, the conditions for the angles of the quadrilaterals are obtained, and it is determined that other quadrilaterals are also parallelograms. So here would be our proof. Quadrilaterals AEFD and EBCF are both parallelograms. So AD is parallel to EF, EF is parallel to BC, and AD is parallel to BC. So quadrilateral ABCD is a parallelogram. Example 3. As shown in parallelogram ABCD, diagonals AC and BD intersect at point O. E and F are 2 points on AC with 4 conditions. AE is equal to CF. DE is equal to BF. Angle ADE is equal to angle CBF. Angle ABE is equal to angle CDF. How many of them can't prove that DEBF is a parallelogram? So in other words, how many of these conditions are useless when it comes to proving that DEBF is a parallelogram? Well, if you slowly go over them, you'll see that one of them cannot prove that DEBF is a parallelogram. So here's our analysis. From the determining method of a parallelogram, we know that if the diagonals of a quadrilateral bisect each other, it can be proved that the quadrilateral is a parallelogram. Condition number 2 cannot prove that the diagonals bisect each other. Only conditions 1, 3, and 4 can, so we can choose B. As shown in parallelogram ABCD, AE is perpendicular to BD at E, and CF is perpendicular to BD at F. So we can connect AF and CE. Prove that AF is equal to CE. Well, because quadrilateral ABCD is a parallelogram, we know that AD is equal to CB and AB is equal to CD, the basic properties of a parallelogram. And angle ABE is equal to angle CDF. And since AE is perpendicular to BD and CF is perpendicular to BD, we know that angles AEB and CFD are both 90 degrees, and AE is parallel to CF. In triangle ABE and triangle CDF, angle ABE is equal to angle CDF, angle AEB is equal to angle CFD, and AB is equal to CD. So triangle ABE is congruent to CDF, angle, angle, side. Therefore, AE is equal to CF, and because AE is parallel to CF, quadrilateral ABE-CF is a parallelogram. From this, we can prove that AF is equal to CE. Class summary. In parallelograms, we have learned so far about its properties, its determination methods, and that parallel segments sandwiched between two parallel lines are always equal. Under properties, we learned that opposite sides are parallel and congruent, and that opposite angles are congruent. We learned the 5 determining methods of determining parallelograms. The 3 skills we learned today is 1. Master the concept and properties of the distance between parallel lines. 2. Use the properties of parallelograms in problems. 3. Comprehensively apply the determination methods and properties of parallelograms. So that wraps it up for our second lesson in chapter 13, which is all about parallelograms. So stay tuned and click the subscribe button to be notified when we upload the next lesson all about medians. So thank you so much for watching Through Inquisitive Kids, and we look forward to seeing you next time.